Hello, everyone. Thank you so much for this opportunity to present my work here. My name is Raveesh Mayya. I'm an assistant professor at NYU Stern. The title of today's talk is Mitigating Spoken Language Barriers in AI-Assisted Programming. And this is a joint work with Rohit Agarwal from University of Utah and Harpreet Singh from UT Dallas. Now, I have to be honest. I'm not completely sure why this talk ended up in AI in education track. And my honest assessment of the situation is that I think the organizers are onto something. I believe that the finding that we have, which is that we can do a lot of input innovation, and you don't always need model innovation, probably is applicable to education research in general. Anyways. So we all use GenAI day in and day out for our work. But if you go out, not in SF, but anywhere else, if you go out and speak to people about their most popular use of GenAI on their phone, they're likely to say that they're going to generate interesting images on their phone. So what I did for this workshop is I created 2 images using Apple Intelligence. So here are the images of 2 kids. They're my kids, actually. They are 2 years apart in their age, and they are remarkably similar in their developmental milestones, walking, biting, everything. Okay. And the younger one is now 2, and I think parents in this room now recognize that this is the age where kids understand most of the things that you tell them, but they cannot reply back in spoken language. And this is also the age when they know that we did not understand what they say. So kids are generally frustrated, and my older one was actually a lot more frustrated about this scenario than my younger one. And everything around them was almost the same, including the same daycare, except that in the daycare with the younger one, there is a new teacher who was using American Sign Language to communicate with kids. And say the teacher taught that to us and the kid. So now the kid communicates to us using sign languages like this, right? By the way, it's remarkable how almost everything that kids want can be done in this 5 signs, okay? So, so the point that I want to make is this, which is what kids want from us are certain actions which they understand well. So it's naturally frustrating for them when you expect them to communicate the same thing in spoken language, which they haven't mastered yet, right? So I believe that, and I want to argue that this insight also applies to the use of GenAI in workplace, where the output need not be spoken natural language. All right. Now back to our GenAI workshop. One of the most celebrated use case of GenAI, the current generation of GenAI, is basically for programming, right? And the AI-assisted coding market is expected to hit $100 billion in a couple of years, which is a large number, right? But there's one problem that will prevent its true potential from being realized, which is that English is not the primary, and for that matter, even the secondary spoken language of a majority of the programmers in the world, as you can see from the GitHub graph to your left, right? And another problem is that many of these languages, especially the Southeast Asian languages, are not high resource language. What do I mean by this? The amount of digitized content available in this language is significantly lower compared to Mandarin or Latin Cyrillic languages like English, all right? So this is a graph that I got from what is the database? Common Crawl database, that's right? And the ones that I highlighted are the 7 Indian languages, and the axis is an exponential axis. So what I want to argue here is that the amount of total language content available in all the 7 languages put together is less than Mandarin, less than English and stuff. And anyone who understands Indian languages know that these 7 languages are completely different from each other, okay? And now the problem with most of these languages is that there's very high density per word. So a combination of high density and low digital content results in what NLP scholars call a token fertility issue, which is a very fancy word to say you need a lot more tokens to represent the same idea in that language. All right. So for example, as you can see in this graph, the one to the left are the ones where there are very popular LLMs, and the one to the right, especially The South Indian languages are to the right most, right? You need a lot more tokens for this. So, and this is an example from my language where this is a very simple translation from English to a very simple sentence in Kannada, and there is 80% more tokens that's required. All right. All this is to say that I don't expect that there will ever be a bilingual large language model in my language, which will ever be as good as a state-of-the-art English language. And so typically in these cases, my choice seems to be between a bilingual LLM, which is mediocre. Not my choice. Let's say someone who has an English problem, let's say, is between a bilingual LLM, which is mediocre, versus an English LLM, which they cannot use well, right? And both of this has productivity implications. Now, thankfully, if the output of any task need not be natural language, there is a third choice. There's a growing body of literature which shows that we can come up with some sort of intermediate representation which people understand well, which can be used with English language LLM, right? For example, an example is a controlled natural language. There's a paper by Amazon researchers which shows that instead of writing the English sentence to the left, if you can write it in the form to the right, the output that this generates, basically asking you to generate an SQL statement, is way more usable. All right. So with this, I will introduce what we did in our study. Basically, we document that language barriers exist in a full stack software development setting. And then what we show is that this can be solved using some sort of domain specific intermediate representation using JSON format. Okay. So the first research question is there language barriers, and basically whether an intermediate representation, basically does this increase the task abandonment due to frustration, and we check whether intermediate representation helps solve this problem. The natural follow-up question is, will that impact people's task efficiency, including completion time and completion accuracy? And we check whether some sort of intermediate representation can help solve this problem. These are our 3 research questions. For this, we partnered with a mid-sized full-stack software development firm in the Hindi-speaking belt of India. This is a full-stack firm which specializes in many of these sectors. And they were, I'm sure we all know this, but a full-stack developer, when someone gets hired as a full-stack developer, they can do the front-end, back-end, the policies, everything, right? So they can develop everything. And this company was actively hiring full-stack developers for their role. So we were able to run an incentive-compatible experiment with them. The incentive here being they're getting a job. Okay. So here is the demographics of the people who participated in our experiment, the job seekers. This is basically to say that the supply of software engineers here actually matches the general supply of software engineers in India. So this is not a very specific group that we are talking about. And so everyone who is interested to qualify for interviews had to go through these 3 steps. Step 1 is where we test their baseline coding skills using some programming task without GenAI. The second task is an English test where we assess their baseline language skills, right? The third stage is an AI interaction skills where the participants have to use AI to generate code, and this is where we run our experiment. So in our final list, we have about 965 candidates, all right? Now, the insight that we use is this, which is all full stack developers use JSON day in and day out, okay? And JSON is a data format where you can represent relationships, constraints, conditions very well. So JSON becomes a good intermediate representation candidate for any any requirement related task. So we came up with this format to the right-hand side called metadata prompting, right, which is using JSON. I'm reasonably sure we think the one to the left is difficult, but trust me, actually a lot of times if you are not good at English, the one to the right becomes difficult. And especially if you're a full stack developer where you already know the format.
You're right.
Yes, sorry. Yeah.
Which one do you mean?
Yes, so I mean the one to the left becomes difficult for people with language barriers. Yeah, the left and the right, sorry.
I think they're easy or difficult for you, Raveesh?
Thank you for this. I'm still not sure, but I hope so. Actually, the second one, equally difficult, is more accurate. Yeah. So now the experiment is this, which is every participant had to do both the tasks, both in English prompting and metadata prompting. But and there were two different types of tasks, task A and task B. And before that, I don't want to forget, the instructions were provided using a video in Hindi. So they had to listen to the requirement documents of a client in Hindi, and they had to write a prompt which they would use with the model, which will generate the code. Because many firms in India are convinced that that's the right way to speed up productivity. All right. The 2x2 crossover design ensures that everybody does both the tasks, task A and B. Everyone does both the prompting, English prompting and metadata prompting, but the combination is different. So one of them does, and the order is different. So one of them does task A in English and task B in metadata prompt. It gets switched over and the format. So that gives us these 4 groups: group 1, group 2, and group 4. So this basically allows everyone is their own treated and controlled. So it gives us a good design for causal inference. Okay, so the first, how much time do I have?
7 minutes.
7 minutes, that's good. Okay. For the first research question, so we want to check whether their language proficiency impacts their task abandonment. So this is where, and this is basically a user level analysis and not a task level analysis. And we ran this only on the first task, which is basically we want to check whether they are likely to abandon more or less in what type of prompting, right? And what we find here is that the graph to my left basically shows that people with English language deficiency are more likely to abandon the task if their first task is metadata, if their first task is English. But with metadata prompting, it's not just that everyone does better, but the difference between the difference that the language proficiency brings in task abandonment goes away, right? So this, and if, as you can see, everyone kind of abandons less, right? So that's basically what we see in the first one. And now the next question is basically, now we want to understand whether there are some productivity measures that gets impacted as well. So for the second research question, we study whether language barrier impacts their task completion time, which is measured in minutes. What I did not mention in the beginning is that they have 90 minutes to complete the task, and the task requirement is quite long. The example that I gave was a baby example. They have quite a long task that they need to do, so they have about 90 minutes. And so we measured their task completion time in minutes, and we want to study how English proficiency impacts their task completion time. And here is the graph. Again, no surprise, what we find is that people with low language proficiency, English language proficiency, actually take a lot more time in completing the task compared to the one with high English proficiency. This is the graph to my left. While metadata prompting, it's not just that the difference goes away, but it gets better for everyone. So everyone completes faster than English prompting, all right? This is about task completion time. And finally, about task completion accuracy. So we measure accuracy by running the solution through a set of test cases, and we measure what's the accuracy, right? So now, because the code is generated by AI, we want to be sure that it's not the AI code which is the problem. So we run the task twice, and we take the average of the accuracy score that we get, which is basically the measure of task accuracy, all right? And this is also a task level analysis. And here what we find is that people with low English proficiency in the English task are, actually have a much lower completion accuracy compared to the ones with high English efficiency. The good news is the difference goes away, and also see that everyone actually ends up having higher accuracy. Okay, so these are 3 research findings. So finally, what we also did, we wanted to be sure that whether it's possible sometimes that you can complete the task, but you completely hate it, right? So we asked everyone whether they preferred English prompt or metadata prompt. And what we find is people with above median below median level of proficiency were likely to prefer metadata prompting over English prompting in all the questions that we asked about their preference, right? So this also tells us that people do explicitly prefer an intermediate representation using JSON over English, all right? So this is a slide to say that we've done a lot of tests to ensure that our finding is not is actually an outcome of what we really want to study and not necessarily a choice of models. So I would like to stop by with this summary where we want to argue this, which is there is a lot of effort that's going on with doing model innovation for equitable use of GenAI, right? Here, what we show is that you can also do a lot of innovation with input as well, right? And that is something which we can start thinking about because there are already state-of-the-art models available. So we can think of some sort of input innovation. But what is very critical is that it is domain-specific. And so this is where the domain expertise comes into picture to say what could be the right intermediate representation. Thank you so much. Yes.
First of all, I want to congratulate you that you picked a really, really interesting question. This is the most brilliant talk that I've heard today.
Thank you.
So it's just the question itself is very interesting. The question about sort of intermediate representation and the ability for someone to create that is not just the question of domain expertise, right? It's also familiarity with the intermediate. I mean, so if I don't know anything about JSON, right, how would I create that representation no matter what my expertise is? How do you bridge that? I mean, can GenAI be used for that purpose?
This is a great question, and I would say that when I meant subject matter expertise, I meant that because this is an education audience, I was thinking of more like the subject matter expertise of how to use this in the education setting. So that's what I was referring to. So I would be certain that there are people who understand that there are some representations which are likely to work with some type of people. Now, I gave this example of Amazon, the research by Amazon. There was another project by Meta folks where they show that when you want to speak about puzzle, it can always be represented using English, but it could be written even better with some sort of a constrained language of English where you can where you can deconstruct one sentence into multiple different sentences. And they show that even so the same model, different intermediate representation, and that's about 80% better in terms of output. So when I meant subject matter expertise, I thought of someone who knows this, that there exists domain-specific intermediate
Language or intermediate
representation. So in our very specific setting, it is JSON, but I completely understand that if I take it to a marketing setting, it's possible that it could be some sort of a markdown language or some other case where it is XML. So I think that is something which is worth thinking about very carefully. But the last part of your question, which is then can that be used with GenAI? I think so. Then it could be a part of the prompt, some sort of tools that you get with your GPTs itself, which you can use. So I'm definitely sure once it is known what works, it can be used as a layer on top. Thank you for the question.
Very fascinating work. I totally echo what Alok is saying, the topic of leveling the playing field in the research lab. So if you go to that slide where you have your control and treatment ones, right? I wonder if I first of all fully agree that there's a language barrier thing going. Next slide. The one with the two, yeah. But there could also be like a verbosity versus structured data. And as someone who has an attention deficiency, I can say this is a nightmare for me.
Yes.
Like my eyes just skip to the last line. Yeah. So I wonder if you did a test of where you represented this text in Hindi as well, and then compared it, we would know how much is the language barrier and how much is the structured versus unstructured.
So in fact, we did 3 or 4 things. I'll start answering the first part of it, which is structured versus not. And I think that is a right hypothesis, which is if you see the difference between English and this one, right? One of the main difference is in any natural language, what you say and how you say it is generally interwoven. And the one to the right, you can actually separate these two out, which is what you say and what you want to say. There's something called separation of concern that comes into picture. So that helps. And that is, so that's one part of it. I forgot the second part, sorry, the second question.
Oh, I mean, I was just saying if you put
Or into the Hindi, right? Okay. So in fact, what we did, we did not convert it to Hindi. What we did was we took their JSON thing, converted it into English, and then we ran it on the model, and we see that the accuracy is higher. Time taken, right? So we know that when this is written and then it's converted into an English statement, it makes no difference. So it's basically, so we are certain about that kind of direction. Yeah. There's one question, but maybe time is up. The time. So I'll talk to you later. Yeah. Thank you so much.